Welcome to Investigation 1.4, the last video of Investigation 1. Diving in, we're going to be looking at the distributive property. We've already played around with the distributive property once before, but now we're really going to play with it again. So let's do just that. Let's dive right in, just like this thing is telling us to. I'd like you to add to your words worth knowing the word distributive property. So the distributive property is specifically the ability to show equivalent expressions. So this allows us to show equivalence by using parentheses. So we're going to be saying, for instance, A times B plus C is equal to the same thing as saying A times B plus A times C. So those are equivalent expressions, and they used the distributive property. Specifically, the A was distributed to affect the B, and the A is also affecting the C term. Next one that we have is what's called factored form. And the factored form of an equation is looking at it as if it were still in the parentheses form. So A times B plus C, this is currently in factored form. So we could also potentially write this as, say, 4 times the side length plus 1. We've looked at expressions like that. That is that pool surrounded by tiles and looking at those corner pieces. The plus 1 is essentially the corner piece. This S is a side length, so we have a side length plus a corner piece, and we have 4 sets of those. We have 1, 2, 3, 4 sets of those. So that is the factored form of the equation when we still have parentheses involved. Now, the next part of an equation, or another version of it, is the factored, or the expanded form. And that's when we take that factored form and we use the distributive property to distribute the A into each term. So we say A times B plus A times C. So that is the expanded form. Or we could also say it's 4 times S plus 1, or we could rewrite that as saying 4S plus 4, or 4 times 1. So this right here is the expanded form of an equation. Very last thing that we're going to be looking at is what's called the commutative property. And the commutative property tells us that we can switch the places of various numbers as long as they're all being added or all being multiplied. So the commutative property tells us that if I have a number A plus B, I could also write it as B plus A. Another way we could look at it is actually putting some numbers in there. We know 3 plus 4 is the same thing as saying 4 plus 3. They both equal 7, but it doesn't really matter what order they're in. We can say 3 plus 4 or 4 plus 3, and we'll get the same thing. Now we can also say the same thing for this. If we say A times B, that's the same thing as saying B times A. We could essentially also write that as saying 3 times 4 is equal to 4 times 3. No matter what, we're still going to get 12 for our answer. It doesn't matter the order of the numbers that we put it in. So using these 3 ideas, or the 4 ideas, distributive property, factored form, expanded form, and commutative property, we're going to look at a couple of problems. So to start out with, we have some drawings. We're used to drawing so far. We've been looking at a lot of drawings in the last couple of days. So we have some pools, 4 of them to be exact, and for each 2, what are 2 equivalent expressions to explain or 2 different but equivalent expressions to explain the total area. So this should say 2 different but equivalent expressions for the total area. If we looked at pool number 1, I see that I have the number 30, and then I have another side that says X and 10. If I look at this, I can look at the area as saying it's the base times the height. And if I were to look at the base for this particular pool, we could say the base of this pool is x plus 10, so it's whatever x was plus an extra 10 feet added to it, and we know our height is 30. So we can look at this pool problem as saying it is 30 the base, or it is the height times x plus 10 the base, the height times the base. Or we could also look at this and say, well, the area of this portion is base times height, so we have 30 times x, or 30x. And this other portion right here is 30, once again, times 10. So 30 times 10, which is 300. So an equivalent expression for this one is 3x, or 30x, sorry, 30x plus 300. That is an equivalent expression for pool 1. So we could either say it's 30 times x plus 10, or we could write 30x plus 300. Let's look at this next one. We can look at the same thing and say the same thing. We have either x times 25 plus x, or we could look at this portion and say, well, that is essentially 25x, and this portion is x times x, or x times x repeated multiplication is an exponent, so we could say x squared. So this is equivalent to 25x plus x squared. Let's continue. Let's look at pool 4 first before we look at pool 3. We have a and b, so a times b, and this other one is a times c, and we're going to add those together. So we have a times b plus a times c, or we could look at it as base times height. So we have a times b plus c, and those are equivalent expressions. We could either say a times b plus a times c, or a times b plus c. This last pool is a tricky one as I look at it. Now the very first thing, we could look at it as the side lengths. We have x plus 2 on one side, and we have x plus 3 on the other side. So looking at that, that's one expression. I have the height and I have the base. So just looking at sort of the area, but just looking at its side lengths. And then we can also look at the actual areas. We have x on one side of this and x on the other side, so x times x, or x squared. We then have also x times 3, or 3x. We have x times 2, or we can write that as 2x, and our very last one is 2 times 3, or 2 times 3 is 6. So we could also write this as saying x squared plus 3x plus 2x plus 6. And we can also finish this off and add our like terms together and say x squared plus 5x plus 6 is equivalent to the x plus 2 times x plus 3. So those are 4 different pools and 4 different ways to show the distributive property, as well as the factored form of an equation and the expanded form of an equation. Factored form, expanded form, factored form, expanded, factored, expanded. So one last thing. We need to use the distributive property to write each of these expressions in expanded form. Our very first one, we have 8 times 3x minus 1. The distributive property is telling me that I need to say I have 8, and I'm multiplying it by the 3x. Then I also have the 8, and I'm multiplying it by that negative 1. So I have plus 8 times a negative 1. And it's important that I look at this as saying a negative 1 or plus a negative 1. So that way I make sure that the negative is sticking with the actual number. So we have 8 times 3, and that is 24, and x plus 8 times a negative 1 is equal to negative 8. So there is my expanded form of 8 times 3x minus 1. Now we have this other one. We have 2x, and we're multiplying it by x plus 3. So we have 2x times x, 2x times x plus 2x times 3. And that looks like I'm going to need to use the commutative property for this one. So I have 2 times x, or x squared, plus commutative property tells me that I can rearrange anything as long as it's being multiplied. So we have 2, we have 3, and we have our x hanging out. The reason why I did that is because I can do the multiplication between 2 times 3, but I can't say 2 times x times 3 and really figure that out very easily. But 2 times 3 is 6x. So there's my expanded form of that equation. Now we also need to be able to do it the other way. We need to be able to undistribute things. And so we're going to actually undistribute something and turn it into its factored form of an equation. So we have this equation right here. We have 3x plus 3x plus 2x plus 4. Very first thing I see is absolutely nothing in common. However, I bet if we were to do a little bit of like term action, actually adding those numbers up and figuring out how many x's we have, we probably could do a little bit more. So 3x plus 3x plus 2, that's essentially 3 plus 3 plus 2, and looking at those times x. So 3 times 3, or 3 plus 3 times 2, or plus 2 is equal to 8x, and then plus 4. Last little bit is we need to find a common number or a common variable that can come out of both of these. If I look at the number 8, I can say this is 2 times 4. If I look at the number 4, I know that's 1 times 4. So my common variable that I can take out of both of these is a 4. So if I were to do that, I'm going to take a 4 out in front, and I'm going to replace everything else, or I'm going to leave everything else behind. So I'm leaving behind a 2, and I still have my x, so I have 2x. And in this other one, we're leaving behind the number 1. So here is my factored form, 4 times 2x plus 1. That is equivalent to 8x plus 4, which is also equivalent to this initial expression, 3x plus 2x plus 4. This last equation that we're going to be looking at, it says 2 times x squared plus 16x. First things first, we need to find a couple of things, or one thing at least, that's similar in both equations. What could we undistribute? If I look at this 2x squared, I see there's a 2 times 1. And then if I look at the 16, I know there's 2 times 8. However, that's not the only thing that I can get rid of. That's not the only thing that I can distribute. I don't need to just undistribute this 2. 2 is going to come out in front, but there's more that's going to be left behind. So I'm going to rewrite this and start to rewrite this. If I write 2 out in front, I'm going to leave behind a 1, and I'm going to leave behind an 8. However, I also see that I have x squared and I have an x. X squared is really x times x, and an x is obviously just x. So I see that I have an x in each of the terms, so I'm going to take an x out. If I were to take an x out, I have this x disappearing and this x disappearing, so really all that's left is an 8. In this other one, I have the x left over, but I also have the 1 left over, so I'm going to leave an x behind. So here is my final answer, 2x times 1x plus 8. Or I could write this as 2x times x plus 8 is equivalent to 2x squared plus 16x. Play around with this concept of the distributive property and factored versus expanded form, and enjoy yourself through investigation 4.1. You are doing for this investigation the entire thing, A through E. Thanks so much for watching, and I will see you later.